Okay, day 14 video. This is for Wednesday, April 15th. Today we're going to talk about exponential functions. Basically, we're just going to be graphing those. An exponential function is any function that has a base and the exponent is where your variable lies. Now, this base can be any number. It doesn't matter. In front of it, there will be the a. So we'll talk about that in a bit. But first, we're going to take a look and see, okay, well, what does our parent function look like? Well, in order to do that, let's get a couple x's and y's and just plot a graph and see what we get. So leave a little room here. Let's go with the 0. So if I put a 0 in here, 3 to the 0, you all remember, is 1. So that looks like a pretty important point. Over 0 up 1. So that's my y-intercept. Let's put a 1 in. So 3 to the first is going to be 3. So I go over 1. I'll go up 3 units, so I'm already way up here. And if I put a 2 in here, I'm going to square it. That's going to become a 9. So this is becoming very large very quick. Hence the term exponential function. Things that grow exponentially grow very, very fast. That 9 is probably even off the screen up here. So it's growing very rapidly. It's not a straight line up there. So let's come back the other way and put in a negative 1. Well, now we got to remember, okay, well, 3 to the negative 1. What does that mean? Well, that means 1 over a positive 3. So that's 1/3. So I'm coming down this way. So I'm only up 1/3. And if I go back to a negative 2, it's going to do the same thing. So 3 to the negative 2 is going to be 1 over 3 squared, or 1/9. So it's going to get small. But no matter how big my number becomes over here, this will never get down to 0. So as a graph approaches a line but never touches it, we have a horizontal asymptote here at y is equal to 0. And 1/9 is already very, very close. So this graph is going to come from almost 0, rise very, very slowly, and then all of a sudden explode. Kind of like the coronavirus is doing. That's exactly what things do. They grow exponentially. Bacteria do it. Money does it. Populations do it. Okay, so that's what the graph, the parent function, it's got 2 key features, and that's what we're going to be graphing. We've got the point 0, 1, and we've got the horizontal asymptote y is equal to 0. So my domain, well, if the arrow goes to the left and the arrow goes to the right, it's going up a lot quicker, but it's still going the whole way out to the right. So my domain is always going to be this set of x's such that x is an element of all real numbers. And you could easily write that in interval notation from negative infinity to positive infinity. All right, now our range. Well, our range is limited by this asymptote. It's either going to be from the asymptote up, or if it were flipped down here, it could go from negative infinity up to the asymptote. So here we're going to start at 0, not inclusively, and it's going to go up to infinity. And it will always be the same exact way. It's either going to go from negative infinity to my asymptote, or from the asymptote to infinity, and that will never ever change. All right, so that's the basic parent function, but we're going to be graphing the transformations of that, and I'm going to put a capital B here. That's not the little b that we wrote up here. Okay, so we're going to deal our A, B, H, and K just like we've done before, and they're the same exact transformations. Okay, so the first example I'm going to do is y is equal to the negative 3 to the x plus 1 minus 2. Now we first got to talk about this over here. We want to list A, B, H, and K and decide what they do. Okay, first of all, 3 is not A, and the base is not negative 3. It is just 3. 3 is the only thing being raised to that negative exponent. This is basically like a negative 1 times that 3 after it's raised to the x plus 1. So A is negative 1. That is going to be a reflection over the x-axis. And there's no stretch or compression. So that's all that's going on there. B is right in front of the x here, 1. So that does nothing. H is the opposite up here, so it's -1, and that's my horizontal translation. So I'm going to be going left 1 unit. K is a -2. We keep that the same, so it's a -2, and that's going to go down. Okay, so as I said, when I graph these, I'm only interested in a nice quick sketch. The first thing we're going to do is we're going to move the asymptote. The asymptote, a horizontal asymptote, is only going to move up or down. If you reflect it, it doesn't change. Either way, if I reflect it, it doesn't change. If I move it left or right, that doesn't matter. So the only thing that's going to affect is K, and that will be true for every exponential function you graph. That's the only thing that's going to affect my horizontal asymptote. So we immediately move it down 2 units. Label it as y is equal to -2. And the only other thing I'm going to move is going to be that original point, 0, 1. I'm going to run 0, 1 through these transformations just like we've done before. A affects things vertically, which means I'm going to take and multiply the y values times that -1. So that point 0, 1 now becomes 0, -1. Or if you thought about it, it was right here. It reflects over the x-axis, so it comes right down to here. All right, B does nothing, so I'm not going to change anything. I'm going to multiply all x's by 1. Well, 1 times 0 is 0. H is my shift left and right. Left and right is x values, but it's addition. So I'm going to add a -1. So that becomes -1, -1. And the final transformation is going to be K, which is a shift up or down. Up and down is the y value, so I'm going to subtract 2 from the -1, becomes -1, -3. So if I go -1 units and -3 units, I'm right here. -1, -3. Now we got to think in our head, okay, well this graph originally looks like this. Now I got to reflect that. Okay, well that reflection over the x-axis is going to look like that. Now, you could easily find the y value by putting a 0 in for x. 0 plus 1 is 1. 3 to the first is 3. 3 times -1 is -3. -3 times -1 is, -3 minus 2 is -5. So this is down at -5. But I'm really not interested in that. I'm interested in these two, about the 1 point and the horizontal asymptote. And then after that, the domain. Well, the domain, for every exponential function is going to be x, such that x is an element of all real numbers, and the range will always be either from -infinity up to the asymptote or the asymptote up to infinity. And in this case, since it's a reflection, I'm down at -infinity up to -2. And that's all there is to graphing that. Okay, here's our second example. I'm just going to continue with the same base 3. If that were any other number, it doesn't matter. Now, the next example, I'll show you a little something. So let's go through and list our A, B, H, and K, and show you how quick and easy these are to graph. All right, so A is the number out front of the base. There is nothing there, so it's a 1. That doesn't do anything to my graph. B is in front of the X. Well, and then remember, no matter what B is, it has to be factored out. So I already have it for you. So -1, and that is a reflection now over the y-axis. So H is my horizontal. Take the opposite, so that's going to be -2. And that's going to go left. And 1 for K, so that's going to go up. All right. The only two things that I really need to graph are my asymptote. Graph that first. K goes up 1 unit. So right there is my horizontal asymptote. Y is equal to 1. Next thing we're going to do is we're going to take that point 0, 1. We're going to run it through the transformations. A does absolutely nothing. So I move on to B. B is going to change my Y values. I'm sorry, B is going to change my X values. Wow. What did I do there? Okay, got that fixed. So we were taking the 0, 1 and not going to do anything with A because A affects the Y's, but nothing's changed because it's 1. B affects my X's. So I'm going to multiply my X by -1. Well, unfortunately, -1 times 0 is still 0. So the point didn't move for the reflection, but every other point does. And we're going to move it left by 2 units. That's going to be my x value. So I'm going to subtract 2 from those. That gives me negative 2, 1. And finally, k is going to add to the y values 1 unit. So it's going to give me negative 2, 2. So that final point now is at negative 2, up 2. That's going to be right here. All right, now you got to think again. My reflection over the x-axis is going to look like this. The range, x is such that x is an element of real numbers. And the domain is going to be now, this time from the domain up to infinity. Okay, so this basically is a reflection over the y-axis because we have 3 to the negative x. There's other stuff with it. But the negative exponent is going to give me a reflection. I want you to remember that when we're going to do the next problem. Okay, the final example today is going to be 1/2 to the x plus 1. And concentrate on this base because it is between 0 and 1. It's a fraction. Well, you just have to remember, how do I get that? Forget the x. Let's take 1/2 and raise this 1 to a positive 1. That could be rewritten as 2 to the negative 1. And then if I have an x out here, I would multiply negative 1, and that would become 2 to the negative x. And now we know we're not going to have a negative b. It's not going to be a reflection, but there's one other thing you have to remember. When you have a base that's between 0 and 1, it is going to be a reflection of the basic one to a reflection over the y-axis. It's just something you have to remember. We're not going to show it as b being a negative. So a is 1, not 1/2. b is also 1 in this problem. H is 0, it doesn't exist, and k is equal to 1. So this does nothing, this does nothing, this does nothing, and this is just going to be up 1 unit. So I'm going to go ahead and take my horizontal asymptote, shift it up 1 unit, and take the point 0, 1, shift it up 1 unit, because that's the only transformation, the only translation it has. And it's going to be the point 0, 2. Now, my graph doesn't go like the normal, typical exponential. I have to know that this is going to give it a reflection, and it's going to come down and then approach 0 as x goes off. I'm sorry, approach 1 as x goes off to infinity. And it's just a little tricky. You got to remember when that base is in between 0 and 1. So domain, negative infinity, positive infinity. Range, set of y's such that y is greater than 1. I'll change it up there and just do them a little differently. All right, guys, that's it for the day. I'll put some homework on there for Google Classroom for you. Remember, keep asking me.